Hi, Assalamualaikum everyone. So, here is our question.
Bismillahirrahmanirrahim. Our first question is to draw structure of J, K, L, M, and N, which are the isomers of butene. J is 2-methylpropene, which has chain isomers because of the existence of double bond located at the first carbon in the longest chain, which is propene, and there is one substituent located at the second carbon, which is methyl. While K is 1-butene because of its double bond located on the first carbon and its boiling point fall between J and L. L has higher boiling point than K because its double bond is located in the middle of its structure. This makes it more stable than structure K. Both K and L have positional isomerism because both have same formula but different position of their double bond. M is cyclobutane while N is methyl cyclopropene. Both M and N is a functional group isomer with alkene, which is cycloalkane. This is why they cannot react with bromine in dichloromethane under dark condition. From the question, J, K, and L can react with bromine in dichloromethane under dark condition. This is because they belong to alkene group and they have carbon-carbon double bond, while M and N cannot react with bromine under dark condition in dichloromethane because they only have single bonds, which is because they belong to alkene group. As indicated in the statement, the escalating boiling point, which is J, K, and L. From the structure, we can see that J has the lowest boiling point because it has the shortest chain. Thus, it has the lowest contact surface area. The lower the contact surface area, the weaker the intermolecular interactions. So this is why J has the lowest boiling point. Next, the question asks us to identify two isomers that give optically active product. So here is our answers. First is K, 1-butene, and L, 2-butene. As you can see from the reactions, when 1-butene reacts with hydrogen bromide, it produces 2-bromobutane. Same as when 2-butene reacts with hydrogen bromide, it also produces 2-bromobutane. 2-bromobutane is an optically active product because it contains hydrocarbon and its molecule is not superimposable with its mirror image. From the equation, we can see that the hydrocarbon which located on the second carbon is attached to 4 different substituents.
So now I will explain you the reaction mechanism that involved, which is the electrophilic addition of alkenes. So first isomer is the 1-butene, or also known as the K, and there are 2 steps in this reaction, which the first step is the addition of an electrophile. So we know that the double bond, which is a nucleophilic site and has a high electron density, it will attract the electrophile, which is this H, and produce carbon cation and bromide. So next step is the formation of product from carbon cation. So bromide, which is a nucleophilic site, and will attract the carbon cation and produce 2-bromobutane. Now we can see the another isomer, which is 2-butene, or also known as the L, and it will undergo in the same reaction. So there are 2 steps in this reaction, which the first step is the addition of an electrophile, and second step is the formation of product from carbocation. So the double bond of this alkene, which is a nucleophilic site, will attract the electrophiles, which is this H, and produce carbocation and bromide. When electrophiles are added to this alkene, the electrophilic addition will occur. So next step is the formation of the product from carbocation. So the bromide, which is a nucleophilic site, will attract the carbocation and produce 6,2-bromobutene. So let's move to the another question, which is the question asked for the chemical test to distinguish between J and M. Alright, the chemical equation and the observation. So for the first one, which is a J is the 2-methylpropene. So 2-methylpropene oxidized by using the cool and dilute potassium permanganate and form the 2-methylpropan-1,2-diols and manganese dioxide. So this reaction is called the Bayer's test. So let's move to this observation. So the observation is the purple color of KMnO4 solution decolorized and the brown precipitate form. So for M is the cyclobutane, and chemical equation for M does not occur because M does not react with KMnO4. It because M does not have a carbon-carbon double bonds, and M is the alkenes. The observation for this chemical test, the purple color of KMnO4 remains same and no brown precipitate form. The question asks for the structure of the isomer C4H8 that shows geometrical isomerism. So for the first one is the cis-2-butene and the second one is the trans-2-butene. Cis-2-butene known as the same site because the hydrogen atom at the same site, and trans-2-butene will known as the different or opposite site because the hydrogen atom at the different site.
Task 2, INEC Component Assessment. The plant that we chose is soy basil or basil or Asimum basilicum. The related Quranic verse that we chose is from Surah Ar-Rahman from verse 10 to 13. And the earth he has prepared for the creatures. In it there are fruits, dates that produce sheeted fruit, stalks, and also corn, with it leaves and stalk for fodder and fragrant plants. Then which of the favor of your Lord will you deny?
والأرض وضعها للأنام فيها فاكهة والنخل ذات الأكمام والحب ذو العصف والريحان فبأي آلاء ربكما تكذبان.
The active component in this plant that we chose is limonene. Limonene is a monoterpene that is cyclohexane 1-in with a methyl group at position 1 and a prop 1 and 2-il group at position 4. It serves as a human metabolite. It consists of monoterpenes and cycloalkenes. Composition of plants chosen. Aside from these nutrients, basil has a variety of vitamin B, traces of iron and other minerals, and a variety of antioxidants. Some of basil oil's possible health advantages include its potential to ease nausea and inflammation, as well as alleviate motion sickness and indigestion. Asim basilicum oil, properly known as sweet basil oil, is obtained from this plant, basil. One of the reactions that we choose that could be occurred for limonene is halogenation of alkenes in inert solvent. At normal temperature, alkenes, or in this situation limonene, react with bromine and carbon tetrachloride to generate vinyl dihalides. The product that we will get is 1,2-dibromo-4, 1,2-dibromo-propan-2-il, 1-methylcyclohexane.